So once again, understanding that the three sides of a triangle have a relationship where two of the sides always have to add up to be bigger than the third side, we're going to use that to find a range of values that would be acceptable based on two sides of a triangle. For example, if a triangle has two sides measuring 5 feet and 8 feet, I want to know what are the possible values for the third side. And so when you think about this, it really comes down to addition and subtraction, all right? To find the lower end of this thing, we just subtract the values, and here's why that works. So if I do the 8 minus 5, that gives me a 3. And basically what that's telling me is that the third side has to be at least bigger than 3. It can't equal 3, but it has to be bigger than 3, all right? So it's got to be bigger than 3, and that's because when you look at the smaller of the two, the 5 plus 3 equals an 8. I need something slightly bigger, so like 5 plus 3.1 would be bigger than that third side, bigger than the 8, okay? So that gives me the smaller of the two, so it has to be at least bigger than 3 feet in order to make sure that whatever I add to the 5 is bigger than the 8, okay? And then if I add the two values together, the 5 plus 8, that gives me a 13. So it's got to be smaller than 13 feet. And once again, the reason for that is because if I do the 5 plus the 8, it equals 13, okay? And since the 8 and the 5 have to add up to something that's bigger than the third side, it means that if those add up to 13, that third side has to be smaller than 13, okay? And so really the easiest way to find out the range of values is I just have to add and subtract. I subtract and say I have to be bigger than that value, but I add and say I have to be smaller than that value. So then if I asked a follow-up question and said, hey, could I have a side length of 10 feet for the third side? The answer would be yes, it falls within the acceptable range. But if I said, hey, could it be 13.5 feet? The answer is no, because it's got to be smaller than 13. And if I said, hey, could it be 3 feet? No, it's got to be bigger than 3. All right, or could it be 13 feet? No, it's got to be smaller than 13, okay? So it's got to be bigger than 3 feet, but smaller than 13 feet, okay? Applying that same thing to the next one, again, we want to know, all right, what's the smallest it could be? It's got to be bigger than what? Well, it's just subtraction. If I do the 12 minus the 6, it gives me a 6, so 6 feet. That's the smallest it could be. It's got to be at least bigger than that. It can't be 6 feet, but it's got to be slightly bigger than 6 feet. So that when I do 6, the 6 that's over here, plus whatever this guy is, it's at least bigger than the 12, okay? And then to find the upper range of this thing, so it's got to be bigger than 6 feet, but it's got to be smaller than, well, I just add the two together. And if I add those two together, it gives me 18 feet. And again, the reason it has to be smaller than that is because if I add these together, it gives me 18. Well, when I add those together, whatever value I get, the 18 has to be bigger than the third side. So that third side can't be 18. It's got to be somewhere in between there, okay? So 6.1 would be okay. 17 would be okay, but 19 would be too big, all right? So again, to find the range of values for the third side, we just add and subtract. We subtract and say it's got to be bigger than that value. We add and say, hey, the third side has to be smaller than that value, okay? So bigger than the subtraction, but smaller than the addition, all right?